Hello, everyone, and welcome to Kilowatt. My name is Bodie, and I am your host, and I am here once again to talk about Tesla's Investor Day. Before we get started with the three-part series, this is part 2 of 3 of Tesla Investor Day, I need to thank some Patreon supporters. So I would like to thank Jeffrey Steve, Bruce W., Isaiah Anthony Howard, Jessica Kirsch, youtube.com/Jessica Kirsch. Jessica was actually in Austin during Investor Day. Bruce C., Elon Muskie, and Rolando. So thank you very much, everybody, for supporting the show. I really appreciate it. And if you didn't hear your name today or yesterday, don't worry, I will get you tomorrow. One more thing before we get to our clips. I made mention yesterday of Tesla kind of making this seem like it was easy. I might even said, I don't think it's going to be as easy as they think. I can't remember. At no point in time did Tesla actually say this was going to be easy. I want to thank Rolando for sending me a message and just letting me know that they didn't say it was going to be easy. They said that that this is a possible and feasible solution. So when I said that I was using it as a jumping off place to talk about the challenges that they would be facing, but I could have done that better by not misrepresenting what Tesla and the team were actually saying. So here's the great thing about this audience, the folks that listen to this show, is when you have something to say and you think that I am wrong on something, you let me know in the most respectful way possible. And that is something that I really appreciate about folks who listen to the show, because I want you to call me on the carpet. I want you to tell me I'm wrong. I want you to say, hey, you probably could have done this better or said this better, because I want to make the show better. But also, I don't want to turn into one of those shows that riles everybody up just to get listeners. That's not my thing. That's not where I want to go with this show. So thank you, Rolando, for doing that. And thank you for everybody else who's done it in the past. It makes the show better, and I appreciate you for doing it. All right, let's go ahead and jump in to our first clip of the day, which is Lars Moravi and Franz von Holzhausen talking about vehicle design and a little bit about Tesla history. This is probably going to be one of the longer clips that we hear today. All the other ones are relatively manageable, but I wanted to keep in the bit about Tesla's history. Now, Tesla's original founders, Martin Eberhard and Mark Tarpenian may have a different version altogether about Tesla's history. I understand that, but they do talk a little bit about the design history, and I think it's relevant for this show. So let's go ahead and listen to that clip.
Hi, I'm Franz. I lead design at Tesla.
And I'm Lars. I've been doing vehicles with Franz for almost 13 years now.
So I joined Tesla in 2008 to vertically integrate design into the company. It didn't exist before. It was a pretty small team. It was tasked with designing the most beautiful, innovative, and well-engineered vehicles on the planet. No small task in 2008. There was not a lot going on in the EV sector then. Since then, we focused on constant improvement in cost, efficiency, innovation, things that you'll continue to hear about today, while continuing to design the most desirable cars. Today, we produce cars differently than we did 10 years ago. But the end result is always an exciting, futuristic, and desirable set of vehicles.
Back then, we only had a handful of designers and engineers like myself, but we had a great vision to radically change transportation.
So back in 2008, where we were designing Model S, we didn't have a factory. In fact, we had a really small engineering team and a tiny design team. But that allowed design to lead all the conversations. It let us innovate forward-thinking ideas like, how do you fit 7 people into a sedan? Or how do you make door handles disappear into the doors? Or putting a huge touchscreen into the center of the vehicle, something that had never been done before.
And then we won Motor Trend Car of the Year.
Yes, and we won Motor Trend Car of the Year in 2013. Our first, great award, first car. Pretty good start. Kind of a home run, I think. But that whole process resulted in a linear process that you see on the screen. We designed first, then we engineered, and then we figured out how to manufacture it.
Yeah, I mean, I think that's really important. When we were designing the car together, we didn't even know where we were going to build it. And so we came up with...
I didn't even know Lars when we were designing.
That's true. We didn't... So once we got Fremont, we were very fortunate, and we figured out the manufacturing solutions sort of like we were flying a plane and putting the wings and building the engine at the same time. So we knew we had to do better.
Yeah, we knew we had to be better in order to scale. And as part of the master plan that you've read, Model 3 needed to be a smaller, more efficient, and more affordable version of Model S. But it had to be equally great. It had to have all the things that people loved in their Model S or Model X, but be much more affordable. And so we approached the process a little bit differently than the first time around. Now we had teams that we all worked together. So we were able to combine design, engineering, and manufacturing process all at the same time. But somewhere along the way, we changed the manufacturing process to be fully automated. And so we leaned into this whole new way of manufacturing a car, but we had already engineered it. So things didn't quite go as well as planned.
It was an amazing product, but it landed us in production hell. Many of us who lived through that carry those battle scars. It was a great idea, but it wasn't the right timing. Like Franz said, automating something that we designed to be built manually is super hard. And we have many, many failed examples of that at the Fremont factory that we ripped out. But some of them eventually still work. This is one I actually worked on with a small team of engineers. It's still running today. And some of the engineers that came by said we couldn't do it are no longer with the company, but it's running, and it's running faster than ever. So we kind of self-imposed constraints on the design when we were doing it to be built manually, and we really didn't think about it. But despite all that, Model 3 is the best-selling EV ever.
Yeah, and Model Y, which is derived from Model 3, is about to pass that. But we knew we had to improve the process further. And with Cybertruck, we designed a vehicle around a vision that actually started with the manufacturing process. And in this case, the materials dictated the design.
Forming full hard stainless steel isn't rocket science, but it sure isn't easy. And it limited the way we could do it.
Yeah, absolutely. It really forced us to think about designing something in a way that you couldn't normally stamp panels. You couldn't form them in a traditional way. So you ended up with very linear bending processes that are just not in automotive kind of language of manufacturing today. But it actually created a very efficient process and one of the most dynamic designs ever, I believe. It's definitely something that's going to change the road landscape.
Hopefully you guys saw it down there and you experienced it. It's definitely real. Those are real trucks. We're on our way to build them. But what that stainless steel opportunity did for us, it has let us rethink the factory footprint. We don't stamp those. That's a huge part of it. We don't even paint them. So our footprint got smaller, and we started to think about innovative ways to take those constraints and make great products.
But that constraint didn't really change the end result of the truck. It's a super dynamic truck, and it has all the functionality you would expect out of any of the other competitive trucks. And the best thing about it, it's coming this year.
So ideally, after all that, we would design, engineer, manufacture, and plan for automation happening together. It gives us the opportunity to question requirements. This is something that is fundamentally only available at Tesla. In the places I used to work and the top manufacturing companies in the world, they don't sit together.
Yeah,
we are one team.
Nowhere I know has all these teams together thinking about these processes from the very beginning.
In fact, all of those engineering teams, manufacturing, design, automation, they're all in one org. They all report to one person. We can't point fingers at each other, so we have to solve them together, which is the best way to innovate.
I really liked what they had to say about all the teams sitting together and working those things through and not working in silos and then figuring out that there's a problem later. I really appreciate that Tesla does that. I think that's a great way to problem solve. I honestly have no idea if other companies do this or not. It may be groundbreaking. It may not. I drive a fire truck for a living. I don't build products, so I don't know how that actually works in the manufacturing realm. They talked a lot about production hell and how they pivoted. One of the things that I thought was a little tone deaf, Lars said in that clip that some of the engineers that came by and said that we couldn't do it are no longer with the company when they were talking about automation and some of the pieces of the factory that were automated that didn't work versus some of the pieces that ended up working. And he said some of those engineers that came by and said we couldn't do it are no longer with the company. When you're dealing with union busting accusations and you've had a lot of anti-employee type stuff thrown at you over the years, not Lars specifically, but Tesla, maybe that's something you don't say because, maybe those engineers quit. Maybe they got fired. Maybe they got pushed out. I don't know. But that's probably something you don't want to say because that's probably going to come up in court at some point. Another thing is if those engineers came by and said this isn't going to work and you can't do it, a lot of stuff in your factory didn't work. So maybe they were wrong about some of the things, but maybe they're right about some of the other things. I don't know. That comment kind of bristled my feathers, but everything else I thought was super interesting. One of the other things that I really appreciated about this talk is when they were talking about having constraints and turning those constraints into advantages. I know in my life, doing the job that I do, there's a lot of times where you roll up on scene of a call and you have the tools that will do 90% of the work that you need to do. And sometimes you'll come up on a job or a call, depending on where you work and what they call it, and you don't have those tools, and you have to kind of punt and work within those constraints of not having those tools to mitigate a problem, or at least get it started until you can call trucks that actually have those tools. So that is something that really resonated with me. Let's see here. They talked about the structural battery pack, just in different ways of making the car more efficient in terms of building it. So that's really cool. In the video, you couldn't see the video, obviously, because this was audio, but they talked about they build the car, they put the doors on, they paint the car, they take the doors off, they install the interior, and then when the car is near the end of the line, they put the doors back on. And it's just like there's a lot of in and out of the vehicle to do this. And what they're doing now is they bolt the seats to the battery pack, and then they kind of build the car around that. And they put the ends on, which is with some of the Model Ys where they have the back assembly and the front all built with the GigaPress, and they just kind of slide that on. So it was a really cool video that they showed. And if you're interested in that kind of thing, I would highly suggest going back to the Investor Day YouTube, and I'll put a link in the show notes and looking at that. But they said that this could end up reducing costs by as much as 50%. A lot of the things that they talk about in this video, it sounds like they're doing some of these things now, but really they'll be doing all of them with the next generation platform. That, again, they just didn't really talk that much about. All right, next up, we're going to hear from Colin Campbell, and he's going to talk about powertrain. And this was a good talk. This is a good clip. So let's go ahead and listen in.
My name is Colin Campbell, and I have the real privilege of leading powertrain engineering here at Tesla. We make the fastest cars that you can buy for the money, whether they're electric or gas. And the Model S Plaid that we're looking at here, it has more than 1,000 horsepower, and pound per pound, the motors in that car are as powerful as jet engines. Our cars are super fun. People absolutely love driving in them. And the other thing that you probably all know about our powertrains is that they're efficient. Our cars go 25 to 30% further than other EVs in our class for the same amount of efficiency. But at Tesla, efficiency means more than just reducing how much energy the cars use. It's about how we develop, how we manufacture, how we refine, and how we scale the powertrain. Now, the Model 3 and Y powertrain is a great example of this broader meaning of efficiency. So since we launched it back in 2017, we've continuously improved that powertrain and the factory that builds it. So the drive unit, the engine of the car, is 20% lighter for the same power. We use 25% less heavy rare earths than when we started. And the powertrain factory, which is behind me today, is 75% smaller and 65% cheaper than the one that we originally built. And what I really want to emphasize is that we did all of this without compromise. Our cars are just as powerful, they go just as far, they cost the same or less, and the factories have the same output. So, how did we do that? We did it by designing the entire vehicle and the entire factory together as one company. And this sets Tesla apart. We have small and highly capable teams, and to make a critical decision, we can have the battery cell chemists, the mechanical engineers, the manufacturing engineers, the supply chain team, the automation designers, the software programmers, all in one room, working together in real time. And that allows us to make decisions that are best for the whole car and to make them really fast. And that approach is unlike traditional automotive engineering, which is really fractured. And if you were to go buy like a premium German electric car, the engineers who designed the drive inverter in that car, they did not work for that car company. They worked for a contractor. And at Tesla, we designed the entire car and the factory that builds it. And I want to highlight a few examples of what we've been able to do in-house thanks to that unique approach. So, inside the charger of your Tesla are transistor packages, and that's at the top of your screen here. And every electron that moves you down the road flows through one of these packages. We designed our own custom package, which is what you're seeing here, and we can extract twice as much heat out of that package as what we could buy off the shelf. And so what does that mean? It means that the silicon carbide wafer that's inside those packages can be much smaller. And silicon carbide is an amazing semiconductor, but it's also expensive and it's really hard to scale. So using less of it is a big win for us. And then on top of that, orchestrating all of these transistors and making them switch in the right ways is computationally extremely intensive. It used to require 4 microprocessors, which are shown here in the bottom left. We have developed our own custom microprocessor. It's purpose-built for high-power electronics. It's half the cost, and it does, in just one, the job of all of those 4. And these are just 2 examples of many that I could use to showcase our expertise in high-power electronics. And that expertise has allowed us to take the cost of the chargers that were in our Model S when we launched it in 2012, both the cost and the mass, and cut both of those in half. And even more important, the power electronics, they're central not just to our cars. They're also central to our superchargers and to our energy storage products, and Rebecca and Mike will be talking more about that. So in addition to the work that we've done in software and hardware, we've also done a lot of work in-house on software. So this is the drive unit for Model 3 and Y, and if we take a cross-section, we see the stator and the rotor, and they're responsible for the core function of the drive unit, which is converting electricity into motion. And our custom software lets us simulate the rotating magnetic field that is responsible for that conversion. And getting that simulation exactly right, it's central to the cost, the weight, the size, and even the sound of the drive unit. And now, you can buy software that will do all of this, but our tools are faster, and they're more accurate, and that was not easy to do. And that allows us to quickly iterate through millions of possible drive unit designs to find the best one. I want to highlight one more area where Tesla really excels because we integrate work that is often farmed out. So when you are making a new product, it's not enough to think about the product itself. You have to think about how you're going to make it at scale. So at Tesla, our powertrain and our powertrain manufacturing equipment is both designed under one roof. The engineers who are designing the motor, they are in the same room as the engineers who are designing the machine that's going to put that motor together. And that collaboration pushes us from day one to design products that are not only high performance, but are really easy to assemble. So, all of this expertise that we have in the powertrain team, in hardware, in software, in manufacturing, it's going to have a major impact on our next platform. In our next powertrain, so the silicon carbide transistors that I mentioned that are key component but expensive, we figured out a way to use 75% less without compromising the performance or the efficiency of the car. And of course, we know that battery cell supply is one of the constraints on the scalability of EVs right now. Our new powertrain is compatible with any battery chemistry. That will give us great flexibility in battery sourcing. If we want to make EVs more accessible to people, they have to be cheaper. We've reduced the drive unit cost to about $1,000, and we don't think any other automaker is even close to that number. Finally, the bigger a factory is, the longer it takes to build. If we can build the same number of cars from a smaller factory, we are going to be able to scale EV production faster. Our next powertrain factory is 50% smaller than the one that's behind me today, even though it has the same capacity. All of these improvements, I think, are going to be transformative for the adoption of EVs and our ability to scale them. There's one more thing that I want to highlight. So I talked about how we had reduced the amount of rare earth in our powertrains. And as the world transitions to clean energy, the demand for rare earth is really increasing dramatically. And not only is it going to be a little hard to meet that demand, but mining that rare earth, it has environmental and health risks. So we want to do even better than this. We have designed our next drive unit, which uses a permanent magnet motor, to not use any rare earth materials at all. So how does all this fit into the master plan? We can make lower cost products that are still efficient and compelling, and we can make them at scale. We're going to use less of constrained commodities, silicon carbide, rare earths. We're going to build them all in compact and high output factories that are easy for us to build quickly. We're going to make that easy to scale powertrains all the way up to the levels that Drew and Elon mentioned at the beginning.
I am 100% on board with this. I want them to improve the factory's efficiency. He mentioned the Model 3 and the progression and how it's improved over time. I think that is great. He does mention that the vehicles now cost the same or less than they did when they were launched, which is not entirely true. We know that because they skyrocketed in price over a specific amount of time. And then Tesla did come back and lower them, which I appreciate that they did that. But, you know, there are people who paid $38,000 for a Model 3. And then there are people who paid $47,000, $48,000 for that same Model 3. So it's not exactly apples to apples there, but I get what he's saying. And I do appreciate that Tesla is saving money by sharing software and hardware knowledge across their verticals so that they can make things more affordable for us and make things easier for them to produce. And then the no rare earth metals in their powertrain, that's great. That's fantastic. Next up, we're going to hear from Pete Bannon and David Lau. They are going to talk about the electrical system. And I cut this part of the presentation down quite a bit because a lot of what they were showing was very visual in nature. So it just wouldn't play well on the audio podcast that I do. Before we get to the clip, I do need to give you a little bit of context on what they're talking about. They started out talking about the wiring harnesses for the Model S and Model X, and the wiring harnesses for the Model S and X were just kind of out of control. It sounds like you had a controller, and then from that controller, there was a bunch of wires that went out and controlled a variety of different things like brake lights and other things in your car that use electricity, right? Over time, though, they found that if there was a problem with the electrical system, they couldn't pinpoint where it was because, you know, that controller sent a signal out and it would turn your brake lights on or whatever. But then it didn't get anything back really saying, oh, this is going to be the problem. There's a short in the brake light or whatever. So what they did was they started using local controllers around the car. And when one of those local controllers would trip, it would send a code. And then the engineers would know, okay, I need to look in this area for the problem. And over time, they were able to improve that. And with the Model 3 and continuing into the Model Y, they used a lot of local controllers to manage those functions. And then they'll talk about this, and that kind of goes further into the next gen plans. And I don't want to spoil that here. Hopefully my rambling made sense and you were able to enjoy this clip.
So I'm going to talk briefly about a few things that we've changed over the years since the Model S. With the Model 3, Tesla started designing an increasing share of our controllers by merging controllers together. And we were able to simplify the design with a significant reduction in wire count and weight. Going from S to 3, we reduced the wire harness by 17 kilograms compared to Model S. And this is a pretty big deal. And just to put that into context, our VP of Engineering, Lars, will deliver a bottle of your favorite spirit to your desk if you manage to save a kilogram of weight from the car. So this improvement cost him quite a lot. Did we skip one? Yeah. The original Model 3 controllers were enhanced and then built into Model Y. Those improved controllers were then moved back into Model 3 when we introduced the heat pump. At that point, we had shared controllers across both cars, which helped simplify our supply chain. Those Model 3 and Y controller designs were then updated and enhanced for the new versions of Model S and X that we introduced in 2021. For Cybertruck, we are now designing 85% of the controllers in the car. For the next gen platform, we're going to finish the job and be designing 100% of the controllers to give us full control of the design and the supply chain at the component level. Having full control of the supply chain at the component level has been critical to Tesla over the last few years as the supply constraints have hampered our ability to build cars.
And with that control comes control over all the software, which enables us to develop features and functionality that we never even dreamed of at the time we designed the hardware. So that's why you see software in your cars getting better and better over time in ways that we didn't even think of when we designed the hardware in the first place.
Mm-hmm. Yeah, Sentry Mode is one of my favorite last-minute changes.
One of my favorites.
With the introduction of Model 3 in 2017, we deleted relays and fuses from the car in favor of e-fuses. E-fuses replace moving parts with solid-state transistors. They provide fine-grained control of the power system to software and allow software to do advanced things like load shedding in the car under adverse conditions. E-fuses also allow for software-controlled retries for transient faults, and they all allow for detailed monitoring of the power system over time.
And the theme you hear a lot about today is software-controlled hardware. And when I think about that in my team, software-controlled hardware is fundamentally about being able to sidestep what otherwise would have been static trade-offs between one attribute or another in a piece of hardware. We are able, with software, to instill intelligence, context awareness, and context-specific behavior into what otherwise would have been a piece of hardware that had to get optimized for one type of scenario. We get more of everything.
In 2022, we completed the transition from lead-acid batteries to lithium-ion batteries, and which use a new toolless connector. We expect lithium-ion batteries to last for the life of the car, so don't expect anyone to wake up to a dead battery ever again. This eliminates a major source of failures for our car. And the toolless connector makes it easier to service the car, and it also includes a software feature to allow validation that the connector has been properly installed at the end of a service event, which removes another source of failures in our cars. Obviously, the mass and volume savings are also significant, which is super helpful. At Tesla, we're always trying to improve every single component in the car, and a nice example of that is the 15-inch display that was originally shipped in the 2017 Model 3. Over time, the cost of the display has gone down 24%. We've been able to reduce the weight by 12%, and we've reduced the power by 33%. At the same time, we've increased the brightness of the display by 50% and improved the color accuracy. So this is one of our favorite things at Tesla, is to make a component cheaper and better. At Tesla, the drive to improve efficiency in the car is never ending. I think of it as like peeling a carrot. You just take a swipe at it, a little bit falls off, doesn't really make much of a difference. But if you just keep at it, over time, it accumulates into a pretty significant improvement. One of the changes that we're looking to make right now is to change something that's been steady for the last 60 years, 12 volts. 12 volts has been, as I said, for 60 years. The demand for power in the car has been steadily increasing to the point where we now have to have pretty large wires to drive over 200 amps of current around the car, which increases the mass and cost. With Cybertruck and all future Tesla platforms, we will be moving to 48 volts. This reduces the current needed by a factor of 4. And since power loss in the harness is resistance times the square of the current, a 4x reduction in current leads to a 16x reduction in lost power while distributing energy in the car. That allows for smaller wires, smaller e-fuses, and smaller controllers. It also allows us to make those heat sinks smaller, or in many cases, remove it completely, all benefiting the car in terms of mass and weight. 48 volts is the future for low voltage design at Tesla and likely the rest of the industry in due course.
We welcome and encourage other OEMs and the entire supplier network to join us on this evolution.
You bet. The number of wires in the car is driven by the number of endpoints that need to be powered and controlled. In the past, centralized control has led for wires spanning the entire car. For Cybertruck design, we have moved to a local controller where the wire is connected to the nearest controller, and those controllers are connected over Ethernet. Wires are routed to the nearest controller where the data is converted into a network packet for transmission to the correct location in the car. To be effective, the network must be reliable, have low latency, and low jitter, and these are all attributes that we've been able to achieve with the current design. The design has eliminated most of the cross-car wires in Cybertruck, and with the next-gen platform, we're going to finish the job and eliminate all of them.
This consolidated vehicle network allows us also to make a whole lot more dynamic changes on the fly to how components in the vehicle talk to each other, rather than the traditional approach of separate CAN buses that are spread throughout the vehicle and fixed in hardware.
And one of the nice things is that you can see the entire vehicle through a single connection, which wasn't possible in the past for debug. For the next-gen platform, we're looking to optimize the controller design across the entire car and across all of the organizations, not just for a given subsystem. Simplifying the wire harness will enable automation. 48 volts will allow us to reduce the size, mass, and cost of the low-voltage system, and is one of the key things to enabling us to scale production of the low-voltage systems for the Master Plan 3.
Okay, I want to talk about two things that I thought were really cool in this clip. First was the 12-volt battery, transitioning from the 12-volt battery, which you get in a standard car, whether it's an ICE car or an EV, to a 48-volt battery, which allows them to shrink components' size, cost, and weight for electrical components, which I had no idea. I figured, and again, I am not a trained person on anything that's valuable. And when they said in the presentation, when they're going to switch to a 48 volt battery, I was like, oh, that's going to add weight. And nope, quite the opposite. That's why I love talking about this stuff on this show. The second thing I thought was really interesting about this clip is that instead of having the traditional wiring harness that they have in the current vehicles, they're going to have a lot of these local controllers connected by a really fast Ethernet connection, which is going to not only help, reduce weight in the vehicle, but it's also going to make it easier to diagnose issues a lot faster, which this is fantastic as well. But let me tell you why I think it's fantastic. The fire truck that I drive is old. It is very old. It's got almost 200,000 miles on it. And as you can imagine, it's got some electrical problems. And these electrical problems are sometimes intermittent. And when we take it to the shop, to the mechanics, and the mechanics look at it and they go, yeah, we don't know. It's not doing it now. There's nothing we can do about it. And then we'll literally drive it home and it will do it again, whatever the electrical problem is. It's maddening. But because a fire truck has so much wiring, if they were to go through that entire wiring harness to find out what's causing that intermittent problem that happens, let's say 4 times a day, it would cost thousands and thousands of dollars. So we just deal with it until it just breaks for good. One of the other things he talked about was load shedding, which is when the system gets overwhelmed and it can't keep up with power, it starts shutting down electrical systems, right? This actually happens in fire trucks. So a lot, a lot. We'll just say a lot. So yeah, I feel the pain on this, and I would like them to bring that technology to fire trucks is really what I'm saying. So Tesla, please share your technology with Pierce, and I'll be very happy if you do. Next up, we're going to hear from David Lau, and he's going to talk about software. I should let you know I cut some things out because, again, this was a very visual presentation. Tesla uses the feedback they get from software to make design decisions. For instance, they removed the sunroof because almost no one used it. I'm going to guess that they made the same decision to stop selling the Tesla charger or to stop giving away the Tesla charger when you bought a Tesla. Because Elon said in the past, the data shows that almost no one uses it. Using things like crash data helps them improve safety. A few months ago, we talked about Tesla improving the seatbelt pretensioner. And when the car thinks it's going to get in a crash, it'll start tensing up that seatbelt so it keeps you safer. David talked about Tesla using driving and charging data to determine future battery sizes. One of the things that Tesla kept repeating throughout the presentation is that they keep hardware and software design in-house whenever it's practical to do so. VW found out that this was a terrible idea when they were trying to get the ID4 out the door. They had produced tons of ID4s, but the operating system and the infotainment system wasn't working. And that's because they were trying to cobble this together from a bunch of different vendors. And when I was in Vegas for CES, I went to the Volkswagen's booth, and the name of the software entity is called something different. I can't remember what it was, but it was owned by Volkswagen. And, they were actively recruiting developers so that they could develop the system in-house. One more really neat thing that Tesla does with this data, and it's really customer facing, but customers may not even notice that the car is doing this, is that as you drive around, the car is, taking measurements, and it notices when there are bumpy roads or speed bumps, and the car will automatically start adjusting the air suspension for the Model S and X, not for the 3 and Y, but it'll start adjusting the air suspension when it knows that these bumpy roads are coming up, and that way it's a smoother ride for you when you're going across these roads. And then after you've passed that, the car knows that that's ended, and it will adjust your suspension again going forward to whatever makes sense, the most amount of sense for that road. So that's pretty cool. Alrighty, let's get to the clip.
So far, you've heard me talk a lot about how we leverage our software systems to iterate quickly on the customer-facing product. But what I haven't talked about, and what we haven't said much about publicly in general, is how we leverage these capabilities in our own internal operations. So for example, in the early days of manufacturing Model S, we very quickly realized that there are a lot of different ways you could misassemble a car. You could forget to plug in a wire, you could not fully set a connector, you could pull a part from the wrong bin. So when we designed our manufacturing processes for Model 3 and all of our other vehicles going forward, we took a page from the software playbook, which says, test early and test often. And we applied that mantra to every single car that we build at every step of the assembly line. So now, when a production associate plugs something into the car, the central car computer sees that connection, confirms that it's the correct part for the type of car that's supposed to be built, installs a software update if necessary, checks configurations and calibrations, and runs a barrage of tests on that thing and all the other things that are connected to it. And if it finds an anomaly that can't be fixed purely with software, it throws an alert immediately that is displayed prominently on the vehicle's display, as well as sent to back-end command and control systems, so that a human can come over and fix the problem before the rest of the car gets built on top of it. And we're taking a similar approach in service through a combination of onboard vehicle diagnostics, natural language processing applied to customer narratives when a customer schedules a service appointment, and a suite of internally developed tools. We are successfully diagnosing, scheduling, and ordering parts for over 33% of customer concerns in service.
Yep, and we also use testers built around our own controllers to test sub-assemblies before they get to the car, which will be even more important as we go to Lars's unboxed assembly strategy.
100%. We'll know with extremely high confidence that before those boxes get put together, that they are that they themselves are assembled correctly. Okay, you've heard at lots of other events about all the awesome things that our autopilot and AI teams are doing to make the car drive itself, bringing us into the future of autonomy. But we've also been thinking for years about all of the other pieces that we are going to need to manage a network of autonomous vehicles. A lot of this has been happening behind the scenes in the form of platform-level functionality that we'll leverage later. But you've seen some of it surface already in terms of features that our customers and our internal operations teams can benefit from. Like in 2021, we built on top of our mobile app phone key and gave our customers the ability to share their car with anyone by sending them an invitation in a text message or an email. Last year, we introduced profile synchronization, which synchronizes your seat, steering, and mirror positions, as well as your settings, media favorites, and stored navigation locations across all vehicles in your account. Internally, we have an app that allows our personnel in engineering, manufacturing, delivery, and logistics to view, locate, and drive all Tesla-owned vehicles at their site. And when customers bring their car into service, when they receive a Tesla-owned service loaner vehicle, we are starting at some locations to automatically add that vehicle to the customer's mobile app account, so that combined with cloud-synchronized profiles and phone key, it's a completely seamless experience. As soon as the customer walks up to that loaner, it behaves and feels exactly like their own car. And all this is built on top of end-to-end encryption and cryptographically signed commands, so that customer data remains private and obscure, and the fleet only trusts commands from authorized parties. So that's a bit of a preview of all the pieces that we're building, looking ahead to our future of autonomous fleets. Synchronization, permissions management, security, and privacy.
I have more notes written on this than what I'm going to say because I'm trying to keep this constrained for time. I know it doesn't seem like I am, but I am now, starting right now, trying to keep this constrained. One of the things that I thought was really neat is the way that Tesla confirms that the part is the right part for where you are putting it. Not only do they do that once you install it, it tests to make sure that it's working with all the other systems. And then on top of that, before they even, pull the part, it's tested to make sure that it works. That's really smart. I think that's fantastic. Again, I don't know if this is anything new. It may just be something that everybody does. I have no idea, but I don't know. It's kind of neat. Again, I love this manufacturing stuff. This is the nerdiest stuff, and it gets me excited and energized. All right, I had to skip a couple of the presentations to save time. I do want to say that one presentation that I skipped was Ashok Eliswani. Hopefully I'm saying that right. He talked about full self-driving and showed off some dojo-like videos. One of the reasons I skipped it was a very visual presentation. The other one was the audio wasn't great and it's hard to understand him. And if you're not looking at the videos and you're listening to the audio, I don't think it's going to be very good for the podcast. But I will tell you, at 1 hour and 38 minutes into the presentation, that is where his demonstration starts. And I would highly suggest you check that out. Now, Tesla has 30 minutes of filler on their YouTube page. If they finally took that 30 minutes out and it started right when the presentation started, it's 1 hour and 8 minutes. But if they still have that filler, the intro music and graphics, then it's 1 hour and 38 minutes versus 1 hour and 8 minutes. Elon talked about TeslaBot, and I didn't think there was much of that presentation that was all that interesting. Much of TeslaBot was built and designed by the same teams that worked on hardware and software for Tesla's other verticals in their business, and I think that's pretty cool. Our next clip is going to be Rebecca Tanucci, and she's going to talk to us about chargers.
Hi there. My name is Rebecca Tanucci, and I lead our charging infrastructure teams here at Tesla. And at Tesla Charging, we have understood since day one that a great charging experience is the linchpin to electric vehicle adoption. And that understanding has meant that we've always taken a holistic approach to charging. That's a word that you've heard a lot here today, but what it means for charging is that we've considered every use case. We think a lot about what it means to charge at home, even if that home is an apartment or condo. And we spend a lot of time thinking about what does it mean to charge away from home, including if that's for daily commuting or if you're going on a road trip. And this holistic approach has led to some pretty incredible results. In 2022, we provided 9 terawatt hours of charging across our various charging methods. Over 50% of that was supplied via convenient AC home charging. And when our customers are away from home, they can visit one of our 80,000 charging points. That includes 40,000 of our beloved superchargers. Now, getting here has meant that we've spent 10 years building charging infrastructure when basically no one else in the industry would do it. And while we certainly have a lot of areas that we want to improve, those 10 years have afforded us the opportunity to get pretty good at charging. First, we have the industry's lowest deployment costs. Our costs are often 20%, if not 70% lower than alternatives. And that goes for both our supercharging hardware and deployments and our AC charging product lines. A lot of reasons that we're able to achieve this, you've heard a lot of them here today. We're vertically integrated. We manufacture and engineer all of our own charging equipment. We share components across our different product lines. And on the supercharger side, we also install and operate all of our own sites. And that's led us to be pretty obsessed with finding new ways to innovate around installation. As an example, we have recently extended our excellence in manufacturing to how we build supercharger sites. We are pre-building 4-post supercharger units at our factory in New York. We load them on a truck, we truck them to site, and then we crane them into position. This method saves us 15% on our deployment costs, and we can install a site in a matter of days. Once we install a site, we also operate it really efficiently. Over the last few years, we've been able to cut our per kilowatt hour cost by 40%. Again, a lot of reasons for this, but one at the top of the list is we've focused on increasing our site utilization. Site utilization is just how many sessions or kilowatt hours can we push through a site or a post. And basically doing that allows us to spread our cost over more sessions, thus lower cost per kilowatt hour. But of course, that's easier said than done, because when we push up site efficiency, of course, the risk is that we have a poor customer experience and we have wait time at our sites. This is where Trip Planner comes in. Trip Planner is our in-vehicle routing or navigation system. Other electric vehicle manufacturers, well, some of them have vehicle-side data. Other infrastructure providers have site data. But at Tesla, we have both. And what that allows us to do is to use Trip Planner to route vehicles towards available sites and away from congested sites so we can balance our utilization without risking wait time. And the results speak for themselves. Over the last few years, we've been able to drive up site utilization by 30%. That means lower per kilowatt hour cost, while also cutting our wait time in half. And we think this can get even better. Today, we're feeding Trip Planner with real-time site information and information about vehicles currently at sites. Going forward, we'll be moving that to projecting site occupancy based on the understanding of what vehicles are currently routing to those sites. And ultimately, our vision for Trip Planner is that it's the air traffic controller for electric vehicle charging across all infrastructure on a global basis. And the last thing we focused on to get here is quicker charge times. We're really proud of what we've been able to accomplish here. We've shaved off 30% of our charge time, average supercharging site time, visit time over the last few years. This has taken improvements on the hardware side, with our software, on our vehicles, and on our infrastructure, and we're really excited to continue pushing this trend down. Looking forward, the job does not get any easier. As you heard earlier, we aspire to a fully electrified global fleet. That fleet, from an industry standpoint, needs 9 petawatt hours of charging on an annual basis. And while Tesla charging certainly doesn't have to supply all of that, it does require that, for our part, we have a few new focuses in order to scale. First, if you want a fully electrified global fleet, all of those vehicles have to have a great and reliable charging experience. So, as many of you know, recently we have started opening up our networks on a global basis. Over 50% of our superchargers in Europe are currently open to other electric vehicles. We've also opened up in Asia Pacific with our first sites in Australia. And just yesterday, we opened our first 10 supercharger sites here in North America and the US to other electric vehicles. We've also invested a lot to be able to make this a really easy experience for our new customers. All you have to do is sign into our Tesla app to unlock a post and start charging. We've also, on physical site changes, we've also added hardware to our sites. They're called Magic Docks. And basically that is installed in areas where we have different charging standards, and they allow for other electric vehicles to come to our site without having to bring their own adapters or hardware. We've also just started installing our 4th generation supercharger posts. Those are being installed in Europe first. And while it's not a big mention, not a big thing to mention, they do have longer charging cables so that we can more easily reach the charge ports of different vehicles. The second thing we need to make sure we do when we talk about scaling all of this charging infrastructure is we need to make sure that it's powered from renewable sources. We're very proud that over the last 2 years, we've procured enough renewable energy to offset the amount of charging we've provided to customers. But as we look forward and we talk about this fully electrified fleet on a global basis, we really want to make sure that the demand for charging more closely follows when renewable sources are available. Now, this chart is on an aggregate basis for the US, and it varies based on what your renewable generation sources are locally. But basically, what this shows is we want to kind of move that charging curve, and for solar and wind in this example, it means more daytime charging. And we think the best way to go towards daytime charging is to install AC charging that is convenient and low cost everywhere vehicles are typically parked throughout the day. So that's really the plan. While supercharging and home charging definitely stay a big part of the puzzle, our teams are currently scaling to install AC charging everywhere vehicles charge during the day so we can power them from renewable sources. So summing it up, while we've spent 10 years installing infrastructure that is low cost, it's efficient, and it provides a great customer experience, we're really just getting started when we talk about supporting Master Plan Part 3. We've got to scale capacity on an industry-wide basis to 9 petawatt hours on an annual basis. We've got to open up to non-Teslas and make the charging experience for everybody really great. And we've got to power all of this via renewable sources. And one more thing, yes, we've got to scale our infrastructure, and yes, we want to power it via renewable sources, but we're Tesla, so we also want to make sure that we're continuing to focus on providing really incredible charging experiences.
She mentions that Tesla can deploy a supercharger or a DC fast charger cheaper than anyone else, and we've talked about that in the past. And by the way, that includes operation costs as well, not just install and manufacturing costs. They did say that they wanted to install convenient AC charging at places where people go, like work, I'm going to guess like stores, random parking lots, that kind of thing. I can see benefit in this as long as there's enough parking for ICE vehicles and or non-Tesla vehicles. And Tesla vehicles. I don't think we should be filling up parking spaces with Tesla-only parking, but I do think that it's a good idea. And I realize that Tesla's opening up their charging network to other companies as well, but you know what I mean. All right, we're going to have one more clip for this episode, and that'll be Tom Zhu and Drew Bagliano. Now, a lot of people are saying Tom Zhu may be tapped for Tesla's next CEO. He was brought up in the ranks, as it were. So he may be in charge of Tesla someday if Elon decides he's going to run Twitter full time or whatever. So let's go ahead and listen to that clip.
Hi, everyone. My name is Tom Zhu. I'm now responsible for global production and sales and delivery service. I joined the company back in 2014, and I've been running the company's business in Greater China and APAC. Today, I'm representing all the gigafactories and talk about how we can make more cars and faster. So right now, we have 4 vehicle factories on 3 continents to serve our markets. The total number of manufacturing employees is over 65,000. This is also including our amazing team in Reno. They are making powertrains, battery packs, and drive unit for our vehicle factories. The total installed capacity in all these vehicle factories about 2 million cars a year. That said, we're always looking for opportunity to grow more capacity from the existing footprint. So you expect this number will grow over time. to build more factories is the start to building more cars, and we're certainly the expert of it. This is the before and after image showing you the progress we made back in 2019 when we built a Gigafactory in Shanghai. So in 9.5 months' time, we built a greenfield project to establish the vehicle factory. And 3 months later, we started to deliver our first customer vehicle. People always ask me, how Tesla can build a factory that fast. Really, we learned from our Fremont factory a lot. We talked to the survivor from the production hell and tried to avoid all the mistakes we made. We decided to design a straight line with the minimum number of up and downs and turns for easier manufacturability and easier construction. We also challenged all the assumptions that people ever know to build a vehicle factory. When we delete and simplified all the redundancies and the buffers, that's helped us to save a lot of time. Also, we have a very strong in-house construction team in Tesla. If there ever a job cannot be done by others better, and we bring this in-house. So we have this in-house construction team, have a full control over all the activities on site, from design, engineering to construction, site management. So this team didn't just build Giga Shanghai, they also built Giga Berlin, Giga Texas, and Giga Nevada. They're really the hero behind the scenes. Like Lars shared earlier, going forward with the new platform, the more modular design and densified Gigafactory, we'll be able to make more cars from even reduce the footprint. And that also means we can build more factories at the same time. With the joint effort of all manufacturing teams around the globe, I'm happy to share, early this morning, we hit the 4 million mark for total Tesla ever built. And the 4 millionth vehicle actually built in this factory. When you took a tour on our shop floor, you probably walked past it. All right. So it took us 12 years to build the first million vehicle. And about 18 months to build the second million. The third million took us 11 months. And just shortly, less than 7 months, we built the 4 million cars. So we're getting better and faster.
Exponential growth.
Really kudos to the team. So, what it takes to ramp a Gigafactory? Well, if you have 600 robots, 10,000 trained employees, or 5,000 human and 5,000 Optimus, and hundreds of processes, you can do it. Sounds simple, but it's extremely hard. So there's two key metrics that we predominantly focused on. It is the overall equipment effectiveness and the cycle time. In Tesla, we're setting the passing grade for our vehicle factories with 90% OEE and 45-second cycle time. What that means, the OEE really evaluates the equipment uptime, the machine performance, and the quality. Simply put, this is the actual production time on a good quality product versus the planned productive time. The higher, the better. 45-second cycle time, that means, you expect every 45 seconds there's a car running off the final assembly line in the factory. And the faster we ramp, the faster we can get the economy of scale. If you look at the chart on the left, Shanghai be able to significantly drop our labor hours per car during the ramp. The little dip there has happened in the last Q2 2022 because of the COVID shutdown. And on the right is the Fremont Model Y shop. Even this is a 6-year-old facility, the team there still be able to optimize the material flow, eliminate all the single point of failure, and drive higher output, hence reduce the labor hours. And actually, this factory keeps setting a new record. Yesterday, they just had a new factory daily record.
Congrats, Fremont team.
Absolutely. So, how can we reduce the cycle time, keep improving efficiency? We follow the philosophy Elon shared about building rockets, which is questioning, basically find the right problem to solve, and we start with delete, simplify, then we try to accelerate, pressurize the line, and find if the solution actually work. And at last, we think about the automation. There's one example in Gigafactory Shanghai. In the paint shop, we find that there's a overlap baking range between the PVC sealer and the top coat. It was done by 2 different ovens, and we decided to combine the 2 processes. Eventually, that helped us, didn't just help us to reduce the cycle time, but also save the 9% of energy consumption and the 9% of the CO2 emission. Also, we commonized the SNX design in Fremont. Right now, we have a common body and common headlamp. We eliminated about 40 parts and reduced about 10% of the cycle time. So all these improvements really help us to get to a faster ramp trajectory. And we didn't just learn from these high volume existing factories, we also learned from the new factories.
Tesla has 65,000 manufacturing employees. That's insane. I don't really have anything else to add to this clip because we're over an hour at this point. So I'm going to leave it here for this episode. I did skip a really interesting presentation by Karn Budhari and Rashawn Thomas. Sorry if I'm butchering these names. I'm so sorry. But they had a really good presentation on supply chain. And that was at 2 hours and 2 minutes into the presentation. And man, it was good. So go back and check that out if you want to hear about production hell and, all of the stuff that goes into getting the supply chain set up so that you can build vehicles. And you have tier 1 suppliers and tier 2 suppliers. It was really fascinating, but in the end, I ended up cutting it for time. All right, everybody, that is it for me this week. If you want to find me on Twitter, it's Bodie at 918digital. You can email me. It's Bodie, Bodie at 918digital. I hope you all had a wonderful day. And like it or not, I will talk to you tomorrow, which I'm not sure if anybody does like it, but I appreciate that you come by anyway.